Okay, so for this video, we're going to be reviewing some linear equations. So that's equations of lines from Algebra 1. All right. So I'm just going to get this camera straightened a little bit better. All right, so here it says multiple representations. What that means is you can look at lines in different ways. You can look at their equations. You can look at the table of values. You can look at the graph, and you can look at a description in words of what.
I remember.
Good. Okay. So let's zoom this in a little bit. So this first question says, write the equation in slope-intercept form. Do you remember what slope-intercept means?
No.
Slope is M, and your y-intercept is B. So this is asking you for y equals mx plus b form is what it's asking you for.
Yeah. Y equals 3
Well, you can't just take this and put it over there without doing something to it. So if you're going to move the 3x, you need to subtract it on both sides. And then that will remove it on this side, and you'll be left with y equals negative 3x plus 4. So basically, if you take a term and move it to the other side of the equation, on the other side of the equal sign, you're going to have to change the sign on it. It's going to go from positive to negative.
Yeah.
Okay, now over here, this is set up to do a table. So we can take our equation that says y equals negative 3x plus 4 and write it right here. And then we can choose values that we want x to be, and we can substitute them in and plug it in and find out how much y equals. So what numbers would you like me to put in the table?
On.
You said,
On.
okay.
Oh.
1, 2, 3, 4, like that.
Yeah.
Let's start with 0. That's an easy one. And then we'll go 0, 1, 2, 3, 4. Okay. So if you do negative 3 times 0, that's just 0. 0 plus 4 is 4.
Oh.
What is negative 3 times 1?
No. 3.
Yep. And then you have to add 4. So plus 4 is going to be like 4 minus 3, right? Negative 3 plus 4 is the same thing as 4 minus 3.
1.
Good. Now I have negative 3 times 2.
Negative.
Plus 4.
Negative.
2. Good. Negative 3 times 3.
Negative.
Plus 4.
5.
Negative 5. Negative 3 times 4.
Negative 8.
That'll be negative 12 plus 4. So, yep, negative 8 is right. Good job. You saw the pattern, didn't you? Good job.
I remember that.
Good job. Okay. So I could plot those points on the graph. So the first point in our table was 0, 4, and then we had 1, 1. So let's put them on the graph. 0, 4, 1, 1. Right? Now, I want to ask you something. Do you remember that you can make a graph straight from the equation because this is your y-intercept and this is your slope.
Yeah.
So we can put, good. So we can put that y-intercept right on the y-axis at 4, which is one of the points that was in our table. And then our slope is -3. If we put that over 1, we have a rise of -3 and a run of 1. So we start at the 4 and we go down 3 over 1.
Yeah, I remember that.
Awesome. So we're going to do it again. We're going to get another point. Down 3 over 1. And then I'm just going to use my ruler and connect my points. That looks pretty good, huh? There we go. That's a pretty good line. Okay. Next, the graph of the function contains the point blank. And when the value of x increases by 1 unit, the value of y decreases by blank. We're going to put the coordinates of the y-intercept here. 0, 4. When the x increases by 1, the y decreased by 3, right? It kept going down by 3 every time. Yeah. So decreased by 3. Oops, I lost track of it. There it is. So it starts at 0, 4, and when the value of x increases by 1, the value of y decreases by 3. Okay. So is the slope of the line positive or negative? If it's got increase together with decrease, what do you think? Is this a positive or a negative slope?
Negative.
Good. All right, so when the x value increases by 2, oh, you can't see, I'm sorry. When the x value increases by 2, what happens to the y value? So let's go to the table. If you increase x by 2, y is going to go down by 3 twice. So how much does it go down if it goes down 3 twice?
Yeah.
Good. So I'm going to put decrease 6 from the table. What is the value of x when y is -5? To answer that, let me zoom out. What do you think you would rather use? What's the value of x when y is -5? Would you like to use the table or the graph or the equation? You choose. Okay, so we're going to write y equals -3x plus 4, and we're going to put down -5 for y. Now what do I do?
I don't know.
Oh, we're going to solve for x.
Yeah.
So what do I do?
-1.
Good job, Connor. So then that's going to be -9 equals -3x. Now what? Good. So what am I going to divide by on both sides?
-3.
Good.
Equal 3.
Good job. So we use the equation to get that. We could even see that on the graph. Look, if you want to see where y is -5, you can go to -5 on the y-axis, and then you can go over to the line till you get to it, and it's right there. And then you can trace up till you get to the x-axis, and it's a 3 on the x-axis. So that's telling you the coordinates of this point are 3, -5. So that's the x that goes when y is -5.
Yeah.
That would work too. Okay. Here's another one. So now, this one, these are blank so that I can do a couple more with you. But I think it would be better if we try something different now.
I understand.
Yeah, I think so too. And so I don't want to keep doing the same thing because I think you're very good at that one. So let's do something different. The linear function represented by this table is what we have. Can we find the y-intercept from the table? So the y-intercept is where x equals 0, right?
Yeah.
We can't see that. We can't see that on this table. So what do we have to do? Do you want me to make the table bigger? I would have to draw like 30 lines on the table. So I don't want to do that. So what if I made an equation from the table? Then I could use my equation just like we did on the problem we just worked.
Yeah.
So do you remember doing this?
Yeah, with minus.
Yeah, so we're going to subtract it. Okay. So 2235 minus 1485. I better write that to the side because I don't have room to. Okay. 2235 minus 1485. I got 1750. That does not make sense. This should be a. Well, maybe that's right.
Oh, wait.
It should be 750, not 1750. Yeah, it's 750. Okay, it's 2,235. Did you get the first number already?
Yeah.
So you did 2,235. Now you need to say minus 1,485.
oil.
So what did you get for your answer? Oh, good. That's what I got. Okay. Thank you for checking it for me. So this is 750. And then on the other side, it's 75 minus 50. That's easy. That's just 25. So do you remember what to do now? This is finding slope. So slope is like this minus this is your change in y over change in x. So we put 750 here and 25 there. Okay? Yep. So 750 divided by 25 is 30. Because doesn't 25 divide into 75 3 times? And then you just put the 0 on the end. Okay? Okay, so that's our slope. That's our m. So what that's going to do for us is now we can write an equation where we go y equals mx plus b. Exactly. We can write y equals 30x plus b. We still don't know what the b is because that's what we're trying to find out is what is the y-intercept. So what we can do is we can solve this for b if we know a value to plug in for x and y. So don't we have a lot of x's and y's in the table? So we can just pick, we can just choose any x and y we want and it will be true. So I'm just going to do the one with the smaller numbers. I'm going to do that one. Okay. So we're going to write y equals 30x plus b, and I'm going to replace that x with the 25 and the y with the 735. So that will be 735 equals 30 times 25 plus b.
Yeah.
And then 30 times 25, we know what that is. That's 750.
Yeah.
Then we go, yep, good job. So 735 minus 750 is negative 15. That's our y-intercept, negative 15. And you remember doing this before?
Yeah.
Good. All right, let's look at a different kind of question now. The linear function, which that just means it's a line, right? The linear function that passes through the point negative 3, 1.5. And also you're given that the value of x is increasing by 1 and y is decreasing by 3. Find out if this line over here is parallel to that one in the description. Wow, that's a lot. Okay, so we could make a table using the first point they gave us, right there, that negative 3, 1.5, we can make a table. So I'm going to use the space over here and do that. I'm going to go x, y, negative 3 and 1.5. And then it says here, when x increases by 1 unit, y decreases by 3. So I'm going to make x increase by 1. That'll be negative 2. But y is going to do minus 3. So 1.5 minus 3. Can you do that on your calculator? You're right. This is 1.5. So it'll be negative 1.5. It's 1.5 minus 3. So 1.5 minus 3. So let me do it over here. 1.5 minus 3. Okay. So since the 3 is larger, you really have to do, oops, I wrote that. So anyway, since the 3 is larger, you really have to do 3 minus 1.5 and then make the answer negative. So 10 minus 5 is 5. 2 minus 1 is 1. It's negative 1.5.
Yeah.
Okay, so then we could do maybe one more if we want. So if we increase again by 1, this will be negative 1, and this will be negative 4.5. Okay, so there's a table. So then what is the slope of this line? Well, if we subtract this, negative 4.5 minus 1.5, that's like y2 minus y1. So negative 4.5 minus negative 1.5, which is plus positive, really. That is negative 3. And then over here, we have negative 1 minus negative 2, which is plus plus. So that equals negative 3 over 1, which is negative 3 for the slope. That makes sense. When you think about what the words mean over here, it says if x increases by 1, y decreases by 3. So that really means that the slope is negative 3, right?
Yeah.
Yeah. Okay. So our slope is negative 3. So our slope is that. Now our y-intercept is important because if you're trying to decide if lines are parallel lines, I don't know if you remember this because we learned this year, parallel lines have the same slope, but what do you know about their y-intercept?
It's not the same.
Good job. So we need to check the y-intercept on this table then. So if I go one more row, I get to 0, negative 7.5 for my y-intercept. Okay. So now if I want to know the slope and y-intercept of this line here, what do I have to do with it?
Well,
I can solve for y and rewrite it like that one that we did. Like this one that we did a little while ago where we got the y by itself because then we knew what the slope and the y-intercept were. So that's what I do. So I'm just going to rewrite this in a different place where I have more space to work with it. So negative 9x plus 3y equals 15. Okay. So if I want to get the y by itself, what do you think the first thing is? Minus what?
we want.
We want to get rid of the x term first so that we can get the 3y by itself. Because you want it to say this. Right? Yeah. Well, this is negative 9. So we have to do the opposite of negative 9. Good. So then that cancels. And we have 3y equals 9x plus 15. Now what? What?
I know with me one night. It only want X.
Yes, but this has an x and this does not have an x. So they're not like terms. You can't add them. Remember, it's going to become an equation for a line, so it's going to look like that. It's going to be an mx plus b. So the 15, this is like your b value soon. And this is like your slope.
minus 9.
If you minus the 9, it'll bring it back to where it was before we started. How do you get y by itself when you have 3y?
The y.
Yes, that's exactly what you want. Now, what I usually do with these kind of problems is I divide each thing by 3 individually. That way I can do 9 divided by 3 and get a number. And I can do 50 divided by 3 and get a number, okay? So over here, 3 divided by 3 is just 1y, so I can write y. 9 divided by 3 is, yep, so I can write 3x. And 15 divided by 3 is? There you go. Now you have it in mx plus b form, which is really called slope-intercept form. So what is your slope?
3.
And your y-intercept is 5, right? Now we're going to compare this line to the one in the table, which is a different line, okay? So slope of 3, y-intercept of 5. The one in the table has a slope of -3 and a y-intercept of -7.5. So if they have different slopes, then they're not parallel, right?
Yeah. Why?
So not parallel. Okay. All right, here's a different kind of question. If you know that this is the equation of your line, x plus 2y equals 5, then look at this graph and what do you think is wrong with this graph if that is supposed to be the equation for it? So the first thing is, this is not in y equals mx plus b. It's not in slope-intercept. So let's make it be slope-intercept first. So we have to get y by itself. So the same thing we did a moment ago. So what do we get rid of first? The x. Then we have 2y equals. Now I could say 5 minus x. I could write it that way, but on purpose, I'm going to write it this way, because I want mx plus b. So I need my x to come first, okay?
No, bye.
Good. So I'm going to make everything a fraction of 2. So now that becomes 1y. This is a little bit difficult to understand, but you know that when there's no number in front of the variable, it's a 1, right? So that's -1/2 x. And then plus 5/2. Well, you can write plus 5/2 as 2.5, or you could write it as 2.5, or however you want, really. Okay?
Yeah.
Okay. So this is an mx plus b slope-intercept form. This is your slope. This is your y-intercept. So they're asking the question, what is wrong with this graph? Well, there's a lot wrong with this graph. Actually, it's not too bad. All right, so let's check the slope. Here's their y-intercept, and here's the next point. So aren't they going down 1/2, down 1/2, down 1/2? So that's good. For -1/2, that's right. That's a -1/2 slope. So what's wrong with their graph?
They don't have the 2.5.
Exactly. They did 5 for the Y-intercept. They messed up the Y-intercept. So we're going to write wrong Y-intercept. Okay?
Yeah.
You're doing really great with this. This is basically reviewing everything you've ever learned about linear equations, and you're doing really well. So here is the last page of our practice today, okay? It says if you're given this linear function, y equals 5/4 x minus 3, where will it intersect the other linear function on this graph below? Okay, so we could just go ahead and graph that and then see where they intersect. So what do I need to put on my graph first if this is my equation?
Y over 1.
Y over 1? You trying to get me to divide by 1?
No, I'm not Y over 1.
Oh, rise over 1. I'm so silly. Okay, I got you. So you want me to, but the thing is, okay, my rise is 5, my run is 4. Okay. How do I start with slope? Slope gets me to go from one point to another point, but I don't know where to begin with it. It could begin anywhere. So I have to look at the rest of the equation. The -3, what is that?
Oh, Y in that.
So that's a place on the line that we can put on the graph. So that's at -3. So we're going to put that on the graph at -3. And then we're going to use the slope. We're going to rise 5 and run 4. So we're going to go up 1, 2, 3, 4, 5, and run 1, 2, 3, 4. Oh, I think we already found the intersection point. So I'm just going to make this graph look nice, but we already know the answer. The coordinates of the intersection are so the coordinates, the x coordinate for that point right there, what is the x coordinate? 4. And the y coordinate is? Good. So we have to write 4, 2. X always comes before y. Okay. All right. Now we have this one. So we're given this graph and we're asked to find the x coordinate for the point blank 243. Well, we can't make the graph go up to 243, so we have to do something different. What do you think we should do?
I don't know.
Well, do you remember on the other page, they made us, hold on, sorry, this paper's in my way. They made us look for some points like the Y-intercept, and we had to make an equation and then work using the equation. Do you remember when we did all this work with the equation?
Yeah.
we can use the equation. So if we know the equation, we can find it. So can you help me write the equation from the graph?
Y.
Yes.
9.
Wait a second. 9 is the y-intercept, right? So when I write an mx plus b equation, which thing is going to be the y-intercept, the m or the b?
B.
Yep. So it's not 9x, it's plus 9 on the end here. We still have to figure out the slope. So let's look for another good lattice point where it's whole numbers. This is a good lattice point right here. And then this is a good one here. You know what I mean by lattice point? I mean, it's going through the corners of the squares on the graph. Yeah.
The I.
Good. Down 2/5. That's perfect. Nice job. So -2/5. There we go. That's our equation. -2/5 x plus 9. So I'm going to write it again over here. -2/5 x plus 9. And it says we want to find the x coordinate for this point that has this y value right here. So you remember what we did earlier when we were trying to solve for b? We plugged in for x and y. Well, right now we're trying to solve for x, but we can plug this y in and solve for x, okay?
Yeah.
So we'll replace the y with 243. We'll substitute that value. So now I have to isolate the x term. So what do I do to get x isolated? Well, if I want this x to be by itself, I have to eliminate the 9. Yeah. Now I'm just going to skip the space here. I'm going to write over here now. So that's going to give me 243 minus 9 is 235. No, just kidding. I'm sorry. I wrote that completely wrong. Oh my goodness. 243 minus 9 is 234. Goodness. And then that equals -2/5 x. Now, what can I do to get this x by itself if I have a -2/5 times it? If it was a whole number, wouldn't you just divide by the whole number?
Yeah.
Well, you can divide by fractions. So we're going to divide by -2/5. Okay?
Yeah.
Do 234 divided by -2/5. 234 divided by -2/5, okay? So we're going to write 234 over 1. Then don't you have to flip and multiply when you do that with fractions?
Yeah.
So that'll be times -5/2, okay? And then don't you have to multiply straight across? So I need to know, what is 234 times 5? Can you do that on a calculator, please? 234 times 5.
Well, now will be
1,107 or 70?
no.
Okay. And then it's going to be over 2. So can you take the calculator and say divided by 2 now?
Mile 85.
Awesome job. Okay, thank you. So that is our answer. That's our final answer. X is 585. Okay.
Yeah.
All right, so we have one more question that they're asking. The linear function y equals 5/3 x minus 4. Find the range values that correspond with the following domain. Do you remember what domain and range mean? Domain means the x values, and range means the y values. So
Yeah, I
yeah, you remember that, good. So they're saying they want us to plug in and substitute these values for the x one at a time and find out which y value goes with each one of them, okay? So, goodness.
negative 5 over 3 by negative 5.
Exactly. So here's what I started wondering to myself, because it's a lot of math to do all 5 of them. I thought, what if we put it on a graphing calculator and we type in the equation? Then we can ask the graphing calculator to show us the table of values, and we can look up the range. We can look up the y that goes with each one of those x's. So I'm going to present my screen and do that for you, okay?
I want to do
Okay, well, let me just show you how then. So let me see. Okay. Okay, so we're going to go to Desmos. And then once you get there, you have to click that thing that says graphing calculator. But then you can type the equation in. So it's y equals, and then you can do 5/3. You know, the slash is right by the question mark on a keyboard, and that gives you 5/3. And then you have to arrow over to get out of the fraction. Because I was down, when I typed it, I went 5/3, and then it had me in the denominator down here.
okay. What do I like this?
Wait, what?
What do I like this?
Are you in Desmos now?
Yeah.
Okay. Are you on the screen that has graph paper?
Yeah.
Okay, type y equals.
Yeah.
5/3
Yeah.
Okay, now, is there a way for you to push a right arrow button? Because you have to get out of the fraction. And then after you do that, press X. And then -4. And when you're looking at the screen, it should say y equals 5/3 x minus 4. If you can see the equation.
How do I arrow out?
To get out of the fraction.
Yeah.
What does your keyboard look like, Connor? Do you have buttons that are like arrow buttons? I have arrows right by the shift. I just have to press the arrow to the right and it gets me out of the fraction. Did that work?
No.
Huh. So you're still down in the denominator where the 3 is? Let me see if I can figure out.
I need the baseball.
Space. Oh, good. And that worked?
Yeah.
Okay, now can you type X and see if it works?
Yeah.
And then you need -4. So if it worked right, you should see a line that looks like it has a positive slope, and it should have a y-intercept at -4. So hopefully that's how your line looks. That's what my line looks like on my screen too. Do you have a graph?
No. Yeah.
Okay.
I do.
You got it to work?
No.
Is it because the X is not where it needs to be in the equation? Yeah. I wish I knew what your keyboard looks like, then I could tell you where you could, some kind of other way to push a button. Let me try one more thing. I'm going to look at doing it this way. 5 divided by 3. Okay, Connor. All right. At the bottom of the screen in the corner, there is a little tab that you can push to open up a keypad on the screen. Do you see it? It's in the bottom left corner of the screen. It's a little tab to open up the keyboard. Do you see that?
I don't want to worry about it.
But I found out how to do the arrow. It's in there. Are you sure?
Yeah.
Okay. All right, well, I'm showing it on my screen right now. So if you watch the video later, you're going to see how to do it because I showed it on the screen and I recorded it, okay? So you have to push the arrow here, and then you can type the X. And then you -4. So anyway, I'm going to hide the keyboard on my screen and I'm going to show you. So there's the graph. And the question on the paper was saying, what are the Y values that go with the following X's? It really said range and domain. But anyway, we talked about domain as the same thing as X. So it says when X is -5, -3, -1, +1, and +3. So I'm going to take the roller on my mouse and use it to help me zoom out my graph. And I'm going to click and drag my graph up just so I can see more of the graph. And I'm looking for when Y or when X is -5. So you can see right here on the X-axis, there's -5. And I'm going to trace down till I hit the line and I'm going to click on it. So I'm going to click right there. And when I do that, it shows me the number. I'm rolling over it with the mouse and it's showing me the coordinate of the number. So it's saying X is -5, Y is, oops, I'm going too far. Looks like Y is -12 point something. -12.3. -12.3. Now I'm going to do the next one they asked about. They asked when X is -3. So I'm going to go find that. Looks like when X is -3, it's -9 for Y. See that? Oops.
Yeah.
So I'm just doing that with my mouse. I'm clicking on the line, rolling with my mouse, and it's giving me coordinates. Now I'm going to go to where X is -1. That's right here. There it is, -1 and -5.667. So that's -5 2/3 because 0.66666 is 2/3.
Yeah.
All right, and then +1. That's right here. So see that number? Whoops. See that number? -2.3333. That's 2 1/3. -2 1/3. Because 3, the 3 repeating is 1/3.
Yeah.
And then here's the last one, 3. So when X is 3, Y is 1. Okay? So that's how you do it. You use a graphing calculator and you can find the values very easily. All right, I'm going to stop sharing the screen. So I know that was kind of annoying to try to deal with it, but the reason I suggested it was because this fraction was going to make it very hard for us to keep plugging numbers in and doing math with fractions. And I knew it would be a lot easier to use the graphing calculator. So that was why I had that suggestion.
No, yeah, no more.
Okay. I know you got frustrated with it, but maybe if you watch the video later, maybe you'll decide to try it again sometime. Okay. It's very annoying to try something for the first time. It really is. And I know it can be difficult to deal with your keyboard over there. So I wish I was able to help you, but I don't know exactly what your keyboard looks like. So anyway, that is the last thing I had to show you. So I'm going to press stop on the video and then we'll talk real quick about when we're meeting. I told it to stop and it's not stopping. Okay, so in this video, we're going to go over a few more things that you need for Algebra 1. You asked me about doing Pemdas, which is really called the order of operations. And then we're also going to talk about quadratic functions, which are the ones that make the parabolas on the graph, the arch shapes on the graph. So let's go ahead and start. What about the video? Two different videos? Yeah, I can do that. So you want one about the order of operations and a different one about the other stuff?
Yeah.
Okay, we'll do that. Okay, so this one is just order of operations. So, oh, that's the wrong title on there. But anyway, this is order of operations. So you called it PEMDAS, which is what a lot of people call it. So that's really just an acronym. Right. And P stands for parentheses and all other grouping symbols. So did you know that a fraction bar is considered a grouping symbol because it chunks your problem into sections? Okay. Yeah. So parentheses and fractions. Okay. So just a fraction bar is splitting your problem into parts. And then E is for what? Good. And then M and D, that's multiply and divide. When you do multiplication and division, they are the same level of problem. The type of problem is the same. So you do them simultaneously on the same level, and you work them from left to right. So just like you read a book. So if you have multiplication and division in the same problem, you do the first one you get to as you're reading it from left to right. And the same thing with addition and subtraction. You add and subtract from left to right after you've done everything else. Okay, so let's do some. So this first problem says 5 minus 18 over -3 times -2. So I'm going to zoom in a little. There we go. So you remember this? Yeah. So basically the way that works is so let's look at number 3. We're not going to work number 3 right now, but you see how number 3 has a problem inside of the parentheses, right? That's what that P means. Yeah. Work it out if you can work a section of the problem. So we're going to work this section because it's not finished yet. So what is -3 times -2? Yeah. Good. So we're going to write everything else, okay? So this is going to be 5 minus 18 over 6. So now we've taken care of the part of the fraction, right? Now what do we do? So now what is left is we have subtraction and we have division because this fraction problem. Exactly. So we're going to divide. So I'll highlight that. So what is 18 divided by 6? Did you say 3? Yeah. Okay, so this becomes 5 minus 3. And then that's 2. Good job. So that is how you do. You always choose just one operation at a time. Okay, let's do another one. So this one has a fraction bar that is chunking out the problem, right? So we could work the top of the fraction first, couldn't we? So what is good? So the next thing we can do is the denominator. So if you subtract a negative, isn't that like adding? So what is -5 plus 3? Hmm?
No.
Did you say 2? Or negative? Good job. So now I have a negative in front of the fraction and I have another negative inside of the fraction. So I need to think of this like it's -4 divided by -2. So what is -4 divided by -2? Good, it's just 2. Nice work. Oops, you can't see what I wrote. So it's 2. There we go. All right, so, oh goodness, we got blurry. Hold on. There we go. Oh, it went out of focus again. Here it comes. So in this one, we do have an expression inside of the parentheses to do first. So we need to do that first. So what is -4 plus 3?
-1.
Good work. So we're going to rewrite everything else. Now what comes next?
No.
Nice job, Connor. I like how you corrected yourself. So -1 times -1 is just +1, right? So that's going to be -2 times +1, which is what? Good work. All right, I'm going to keep going down the page because that way I don't have to reposition the camera, and then I'll just go get the other problems after. So in this problem, you see how there's 2 sets of parentheses, right? So what we have to do is we have to look at what's inside of the parentheses like it's its own separate problem and just not look at the rest of the problem. So when I look at what's inside of the parentheses, what should happen? Good job. So we'll do that first. Good. So we're going to have 4 minus 1 minus 4, right? So now what? I'm going to switch highlighter colors just because I'm using up my... Look at you go. So then it's 4 minus -3, and that's the same thing as 4 plus 3. So that is good work. All right, let's do this one. Okay, so that's going to be -2 over 5 minus 6. Then we'll do this. What's 5 minus 6?
1.
Almost.
-1.
Good job. So now -2 divided by -1 is good work. All right, so now we're going to go to the other side and do 3 more. So what should I do first? Good. So just this one, right? So this is going to be 2 times, what is -4 minus 1?
-1.
Good job. Okay, now what? We have multiplication and we have addition.
Multiply.
Good. So what is 2 times -5?
-3.
So -10 plus 3.
-7.
Nice work. All right, let's look at number 6 here. This one's weird. It doesn't have any parentheses or any exponents, and it only has subtracting and adding. So how do you know what to do first? Do you remember? Mm-mm. Do you remember when I put the mark on here, I said addition and subtraction go at the same time from left to right, just like we read a book. So what is the first thing you see when you read the problem?
1 -2.
Exactly. So that's what you have to do first.
-1.
Good. So this is going to be -1 plus 1 plus 2. Now I do that. What's that? -1 plus 1 is?
0.
Right. So now we have 0 plus 2, and that is 2. Good work. All right, let's look at number 8. This is the last one. What do I do first?
I don't know.
Well, you're supposed to look for grouping symbols first, right? Parentheses and fraction bars. So isn't there a fraction bar?
Yeah.
So is there a problem that you can do that's part of your fraction?
-3.
Good. So that's what you should do first. So then you have -1 plus 8 over, what's 5 minus 3?
No.
Good. Now what do I do? If you have addition and division, you were saying 8. So you want me to do this first. That's right. So that will be -1 plus 4. And then what is -1 plus 4?
3.
That is it. So that is exactly how you do these. Okay, I'm going to press stop on this one, and I'll start another video for the other things. Okay, so we're going to talk about factoring, and I want you to watch me do this, and maybe you'll remember exactly what to do. I'm not even going to say anything. I'm just going to do it, and I want you to try and figure out what I'm doing. Do you remember doing that before, Connor?
Yeah.
So this is called factoring, and what we're doing is we're looking to find factors of 12 that have a sum of 7.
We can use the quadratic equation.
You're right. You can do quadratic formula too. Now, when you do have it factored, do you remember that if you do have it factored like this, since the whole thing equals 0, then each one of those equals 0, because if they multiply together to be 0, then they must be 0.
Yeah.
So that's 0 and that is 0. And then you can solve each one of those. So that means this one is -3. This one is -4. Yep. So that is called factoring to solve a quadratic function. Okay. So I'm going to do what?
How can we do it with the formula?
Well, we can do it with the formula too. So why don't I do like 3 more of these with the factoring, and then I'll show you with the quadratic formula after, okay?
Yeah.
Okay. So I'm going to take that number right there, and I'm going to write it over here. Now this one's negative. Since it's negative, instead of adding, you remember on this one I put down the positive and I added the numbers? Since this one's negative, yep, I'm going to subtract. You got it, buddy. So I'm going to go 1 minus 15, 3 minus 5. Now 1 minus 15 is -14, but I want -2, so that's not going to work. But if I do 3 minus 5, that is -2, isn't it? So that's the one I want. So that means that the numbers that go in the parentheses for the factors are +3 and -5, k plus 3, k minus 5, that equals 0. And then each one of these equals 0 itself. K equals -3. K equals +5.
Yeah.
All right, let's do another one. So this one is +16. 1 and 16 is 17, but I want +8. 2 and 8 is 10, and I want 8. What else multiplies to give you 16 besides 2 and 8? Well, 16 does not divide by 3, but it does divide by 4. It's 4 times 4. So if I do 4 plus 4, I get 8.
8.
So I'm going to write n plus 4, n plus 4. And then those are really the same thing, so I'm only going to write it once. N equals -4 is the solution. It's just 2 of the same solution.
Yeah.
And then this one is -8. 1 minus 8 would be -7, and that's not right. It needs to be 2. 2 minus 4 would give us -2. So that's not quite what we want. We want +2. Well, if I switch these signs and make them negative, like this, -2 plus 4, won't that be +2?
Yeah.
So that's what we want, -2 and +4. X minus 2, x plus 4. So now x minus 2 equals 0, x plus 4 equals 0, plus 2, minus 4. And those are my answers, +2 and -4. Okay, so you said you wanted to see quadratic formula. Okay. Oh, the doggy is wanting back in. I will be fast this time. Okay, so now for quadratic formula, we write out the whole darn thing. So let me do it with this problem. So what you do is you have to remember standard form. Standard form for any quadratic is ax squared plus bx plus c equals 0. So
Yeah.
the a is the number in front of the first term that's squared. Well, there's no number here, so it's just 1. So a is 1. Then the b is the number in front of the term that's not squared. That's just the first to the first power. So that's this -2. Good job. So these are the numbers that go in the formula. But here is the quadratic formula. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we're going to do. We're going to put -b, so that means the opposite of b. So b was -2. So the opposite of -2 is +2. So we'll put +2 there. Plus or minus the square root of, now we need b squared. So that's going to be -2 squared minus 4 times a times c. So minus 4 times a is 1 times c is -8. And what? Nice job, buddy. So now we have to work it out, okay? So what is -2 squared? Yeah, nice work. And then 4 times 1 is 4. And 4 times 8 is 32, right? So this whole chunk here is 32 with a negative times a negative, which is positive. So we're going to put plus 32 for that part. Then we need the fraction part to go the whole way. Yep, over 2. Now, what is 4 plus 32? What's 4 plus 2? 6, right? So 4 plus 32 is 36. Okay? So now tell me, do you know what number times itself equals 36? Nice job. So the square root of 36 is 6. So now we write 2 plus or minus 6 over 2. Almost done. So this means 2 plus 6 over 2 and 2 minus 6 over 2. So 2 plus 6 over 2 is good. And 2 minus 6? That's -4. So this is -4 over 2, which is -2. So your two answers are x equals 4 and x equals -2. And those are the answers. Okay?
I like the one.
Do you like it better than factoring?
Yeah.
Yeah. So you want to do another one of these?
Yeah.
Okay, let's do one more. So let's do this one right here. So here's A is 1, B is -7, and C is 10. So I'm going to write the whole formula for you. negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is the opposite of b? Good. Now I need to put negative 7 squared minus 4 times what?
1
Times what? 10. For the C. I was on the C. All over 2 times.
1.
Yep. So now this is 7 plus or minus the square root of. Do you know what 7 times 7 is?
49.
Good. So negative 7 times negative 7 is also 49. Now, what is 4 times 1 times 10?
1.
Good. And we have it a minus here, so it's going to be negative 40. All over 2. And what is 49 minus 40? No, it's just 9. It's like 9 minus 0. It's 9. So this will be 7 plus or minus 9 over 2. So what number times itself is 9? What's the square root of 9? Huh? Did you say 1?
3.
Yeah, 3. I just misunderstood you, I think. Okay, so now we split it. We've got 7 plus 3 over 2 and 7 minus 3 over 2. So what does that give us? Good. Good. So, and then 4 over 2. Yep, 2. You got it, buddy. So those are your answers, 5 and 2. You're really good at that quadratic formula. Nice work. So there is one more way to solve a quadratic, and that way is graphing. Okay, there's 3 ways. There's factoring, there's quadratic formula, and there's graphing. Okay, so we want to graph these. So what I'm going to do, I just have 4 more problems that we're solving. I don't know if you can see all 4 of the ones we didn't solve. This one, this one, this one, and this one. And what we're going to do is we're going to graph them. So I'm going to present my screen to show you how to graph them on Desmos. Okay. Let me see.
Can
we wait? Wait, Connor. Your sound quality was real bad for a moment. Can we do what?
No. I don't want to use the graph.
You don't want to see the graph?
I don't want to use the graph.
You don't want to learn how to do it that way?
No.
Why not?
because I want the quadratic formula.
Okay, but when you get to Algebra 2, you will have problems that you won't be able to do with quadratic formula, and you'll have to learn how to do the graph way. It's not going to take long, I promise. I'll show you. It's quick. So that equation says x squared minus x minus 2. So I'm going to go show it to you. So next year, when you're doing some Algebra 2 kind of problems, you can just tell me, you know how sometimes you say to me that you're going to do the calculator? You can always just say to me that you want me to type on this calculator, and then I will share my screen like I'm doing right now. Okay? So look at the screen. See some points on the x-axis that look kind of like they're gray points. I'll point to them. Here's one of them. Do you see it?
Yeah.
And that's the other one. Those are the solutions. So when you do the quadratic formula on this one, it will say the answers are -1 and 2. So the x coordinates, the x-intercepts are the solution. Okay? So that one at 2 and that one at -1. Those are the answers. Now I'm going to do the one that we just did together using the quadratic formula. I don't know if you remember, but the one we did together a moment ago had 5 and 2 for the answers. And it was x squared minus 7x plus 10. So I'm going to type that on here, and we're going to see if it has the same answers on the graph. There's 2. There. That's really fast, isn't it? All I had to do was type a couple of numbers, and the graph showed me the answer. Here's another one. This is a new one. Oh, here's the other one that we did with the quadratic formula earlier. It said n squared minus 2n minus 8. And it had the answers of 4 and -2. There's the -2. There's the 4. Okay? So I'm done. That's all I wanted to show you. So I know that the graphing is not your favorite, but I needed to talk to you about how the 3 things have the same answer. It's really important to know about that. Okay? To press stop? Is that what you said?
Yeah.
Yeah.